all good. Cool. Are we good to go? Is the microphone here?
No,
good?
not yet.
Mic?
Okay, that's good.
Cool.
Okay, I'm inviting all of you to come as close to the center here as possible.
Please.
Since it sounds like we're actually living in a war zone. And I suppose that lots of people in Ukraine don't have this level of noise on a day-to-day basis. Sorry, that was a rant.
Are you all good to go?
Okay, thanks so much. So feel free, even if you've during my talk want to move closer because you can't really hear what I'm saying or see one of the screens, just feel free to move around. And if this is totally bothering you, feel free to leave as well, right? So the objective of this talk is to, as I said, it's to bluff your way into zero trust. There's a ton of buzzwords. Nobody knows what they're really talking about. People are contradicting one another. And maybe, you want to get out better at the other end. And that doesn't help if you don't know some of these buzzwords, right? It's up to you what you do with them. I'm not responsible for anything that you do with them. But I think I have some help for you to to conduct a conversation, right? These slides will be up on my website. And maybe also on the Y side, but it's going to take 1 or 2 more days because I was just fixing up stuff. I'll have some helpful reminders for how you can find that. So some of the slides I won't talk about in detail. They're more for any consumption a little later. So what are we talking about? Well, just really the short one-line explanation of zero trust is no implicit trust of anything, only allow rules. And John Kindervag, he's quoted on this T-shirt, although he didn't actually say this. He said, well, think of it. All data breaches happen inside an allow rule. If data leaks, it is because we allowed it to leak. That's the short, first approach. And then we all kind of familiar with the fact that if we trust everything in our data center, that means that we have these huge insider threats. Because everybody in the data center or close to it is potentially then a threat. Can you still hear me in the back all right? I'm trying to talk out very loud, but no. Anyway, then what zero trust as an approach, as a strategy, invites us to do is to describe trust explicitly, right? And I'm going to go over a couple of parts of that, variations of that, and ways of implementing that, either on a business level or on a technical level. And it's hard, right? The devil is in the detail, right? And I'm going to get back to some of that in a moment. We also want to do this in a somewhat technology-neutral way, right? We want to describe this in a somewhat abstract way, but not as abstract as thou shalt have proper governance, because that's a little bit too abstract, right? You want to have it as specific as possible, but still technology neutral. Why is that? Because then it can be understood by the non-techies whose data is at stake, right? It's not, as an IT professional, it's not our data that's at stake, it's the data that's at stake from the business people or the consumers out there, right? So let's flash back a little bit into the history. The whole idea of zero trust was introduced by John Kindervag when he was working at Forrester, and the paper that he wrote was actually No More Chewy Centers. And I guess, who's in security here? Right? Well, most of you, so you probably heard of the concept, hard shell, soft inside. Once you crack the egg, everything is just wide open. And that was what he was trying to sort of expose as a very ineffective security strategy. Now, after a lot of talk and speaking at conference and whatever, he got invited into a committee that eventually resulted in the U.S. Executive Order 14028, which is dated about 4 years ago by now. So it's the Biden administration, and this executive order is not cancelled, or at least not yet. whereas most other stuff that Biden did was canceled by Trump. In particular, the AI order that Biden set up was completely eradicated by the Trump administration, losing a lot of security there. Anyway, this stuff is taken seriously in the US. You know, last year there was a Department of Defense online symposium that lasted for like 2 days. That had 2,000 attendees. This year, that same conference, I attended most of that, by the way. It's all public stuff. The Americans are not really secretive about this. The attendance was doubled, right? So something is happening over there. Some people are trying to be smart about it. And if you search for it, there's a ton of public Department of Defense material on how to do this. For example, the US Air Force has a really detailed strategy document and a roadmap inside. That's about 50 pages long, if I remember correctly. I read through most of it, and it's a pretty decent document, right? It's fairly practical for a document at that level. But the most important thing about that document is that it actually exists, right? People are taking this seriously. Well, in this country or across Europe, it looks like actually nobody is taking this seriously. Then another historical fact is that the Cloud Security Alliance, and I'm a long-time partner of the Cloud Security Alliance. They drove a lot of my business over the past 15 years when I was a cloud security trainer, and also Zero Trust trainer, and a couple of similar things. The CCZT, it's a fairly decent body of knowledge. You can download it for free, right? I'm going to get you. So there's nothing secret about that. You can do an exam and then you kind of know a little bit, right? Because the whole thing is a huge beast in a way. And I'm here to try and give you a perspective on the entire field, but also how can I get started? Because it's huge. And I hope to bring some new thinking to you. Anyway, are there any products? Yes, there's a lot of zero trust washing going on, so to say, but none of these projects is a project to rule them all. I'll have a screenshot of one of the products at the end that gives you some perspective. Okay, why should we be doing major zero trust? Well, because in the whole grand scheme of things, it sounds really simple, but where do you start, right? Who of you is old enough to remember the movie Love Story? Right? No, well, okay. Damn. Well, there goes my joke. And the rest of you have bad memory, right? And there's a really moving song in there. Where do I begin to tell the story of? Well, that's the same with zero trust. Where do we begin? Anyway, one of the major early use cases for zero trust that apparently a lot of people and companies find useful and relevant is VPN replacement. I was listening to a podcast the other day, and from a pen testing. No, it was not a pen testing guy. It was a guy who was like the cleaning man. Like he cleaned up after a data breach, right? And he said, well, there's two things. The typical entry is through the VPN. The typical target is the hypervisor of their core systems. But the VPN is the target. Because how you set it up, the VPN, it's like, okay, who has access? Okay, and then you have access to the entire frigging infrastructure, right? So much for reduced trust. Now, cloud and micro-segmentation in general are great use cases because it's fairly easy to do there if you don't mess up, right? We still see companies that have one cloud account for Amazon that represents their entire application portfolio. Bad practice. In the cloud, these security groups basically are firewalls around a single machine, if you want. And they're free, right? You set them up through Terraform, right? It's a no-brainer to do that, but you have to do that. Then DevOps pipelines, they really need some zero trust approaches. As a matter of fact, I have a really small example at the end. The admin access, so privileged identity access. Now, who of you has experienced system admins who log in as system admin and then do their day-to-day job, right? Okay, yeah. And how many of these people were there in the organization? More than 5, right? More than 10. These are the stories that we hear, right? You have to nick one password and your total infrastructure is toast. Business processes where, so I mean, zero trust is not just a technical concept. You can also apply this to business processes. Are you all right? It's the war zone, right? Yeah, right. But you can't get much closer than this. Maybe if you move more to the side, then you have just one speaker instead of two speakers. Yeah. What are you saying? Yeah. Anyway, that's why we have PowerPoint slides, so you can get back on track when you don't hear what I'm saying. Pro presenter tip. So because business processes, and I'll get back to that, because the real risk should be managed by the business process owners. And to the extent that they can use attributes of people who access that, they can do better, let's say, operational risk management. And then you have third party and supply chain. This is obviously, well, SolarWinds, anyone? Well, you get the idea. So what are the benefits? Because there's also, we hear a lot of stories from companies that do stuff like this and actually save money on the right-hand side. A couple of things. Okay, better security, right? Cheaper security. It's less work to get the same result. Easier compliance. Compliance is a drain on resources, right, for most companies. Better user experience. This has to do with, let's say, onboarding users on VPN type of situations. Because if you can sort of derive it from their prime identity, they don't have to go through extra hoops. Less re-authentication, faster provisioning, that's the stuff. Another one, cheaper licensing. Of course, as I said, your mileage may vary, but if your licensing is tied to the number of users that have access to your systems, and you don't know how many users really have access, you may be paying more than you're comfortable with. And of course, fill in the blanks. Okay, what's next? Actually, I have the wrong screen here. I need to get this back in a moment. Yeah, this is much better. So, did I already? You're on the right slide, right? Okay. So, I said, trust is a vulnerability. Now, I didn't make this T-shirt. I got this from some Norwegian friends. The company is no longer operational, but because they were merged into another one. But it's a nice way of saying that. All trust, in a way, is a vulnerability. And the only thing that you can do is reduce that vulnerability by reducing the implicit trust, right? The assumed trust. I assume, like, okay, when somebody is on a network, we assume that he is an employee, right? You all know how stupid that idea is. And the way that somebody like John Kindervag expresses this is, well, we trust people, we just don't trust packets. It's about the packets, it's not about the people. Does the packet adequately represent the person? Right, that's the thing. And I had these discussions all the time, and people say, what do you mean zero trust? Don't we trust our people? Yeah, sure. Well, most of the time at least. We trust our people. We just don't trust the North Koreans that are in possession of their account credentials. That's the problem, right? And you're talking about that. You're not talking about that. Okay. So how does this work, and how can you get started? And the core idea, really, from a technical, operational perspective, is we want fine-grained allow rules on what zero trust people call the protect service. Now, what's the protect service? This is a really interesting concept. And John Kindervag has these presentations. You can find some of them online, where he has a big picture of the presidential limousine, and there's a couple of layers of people with that are talking in their sleeves and long coats. You know the people, and they say, well, the president is the protect service, right? If at the end of the day the president is still alive, then these people have done that job, right? How does that translate into a IT world? Well, here's a diagram that I've created to make that visible, right? So the typical attack surface approach is basically saying, well, on our outer perimeter, the one where let's say the end of our world, beyond which is the the bad internet, that's where we start protecting. Sure, you can start to do some protection there, but there are some disadvantages to that approach. What the zero trust people say, well, you really want to start with the protect service. Where is the data that you care about? Typically the data. And can we make an enclosing control boundary as close to that as possible, right? Because everything between here and there is a control gap. It's a window of opportunity for an attacker, right? And you don't want those. And there's a couple of more things to add to this, because we also hear on a regular basis that the attacker, right, has to find only one way to enter here, right? Whereas as a defender, we have to plug everything across the entire attack surface to make sure that that does not happen. Sound familiar? Right? Okay. Which means that when you're 95% done with plugging the attack surface protection, you're basically still at zero protection, right? Whereas if you take this approach, you go like, oh, well, what's the protect surface? Obviously, I would likely start with the server that has the most important or valuable data, right? So let's say we have one server that represents 80% of our value, right, that we want to protect. If we plug that one, we have spent 5% of the total effort and get 80% of the protection that we want. Now, I think that makes for an interesting business case, don't you? Okay, that's the core idea, one of the core ideas, protect service. Figure that out. Okay, but how do we do that? That's a more interesting question. Where does this zero trust stuff live? And this is where it starts to become confusing, because any vendor will gladly sell you a box that says, hey, buy this box and now you have zero trust, right? But it's not that simple, because it lives everywhere. Zero trust lives in the workloads, it lives in the hypervisors, it lives in the SDN controllers, it lives in the network fabrics, and many more places. And I will go through examples of some of them in a bit more detail in a second. So this zero trust enforcement, so to say, is all over the place. Now, one way of looking at these places and is what in the jargon is called the DAS elements, right? And the DAS elements are data, right? What is it that you want to protect? That's really the core. Because, yeah, I mean, what is it that we typically want to protect? Well, data. Now, as long as data doesn't leak, right, we're typically pretty cool from a security perspective. Then we have done 95% of our jobs, more or less. The other is applications. Now, why are applications important? They hold the data, right? And they control access. Or at least they implement some controls accessing that data. Then we have assets, as these people call it. I mean, I didn't make this up. I'm just trying to help you understand the jargon that other people have created. And it's jargon. Anyway, devices run code. Probably malicious code. Now, what's malicious code? You could call them unauthorized applications. Like botnets phoning home stuff. That's an unauthorized application. And that sounds bureaucratic, and in a way it's funny to say it like that, but it's just malicious code, viruses, whatever. And then you have services. And services are externalized applications. So we have a different way of protecting access to them. But they are still applications, right? Okay, DAS elements. So this is a way of slicing and dicing your estate to see where you can have a vector of intervention, so to say. Now, what the Zero Trust world also uses a lot is the concepts of PDP and PEP. Anyone know what that is? Raise your hand. Okay, a couple of people. Can you actually explain the difference? Yeah. Yeah, right. But if you dive deeper into examples, you go like, well, wait a minute. Enforcing is also making a decision, right? So it's a bit fluid. Anyway, I'll help you understand this, or at least I'll help you understand where the friction is, because the concepts are fairly decent. Okay, decision point, enforcement point, and there are subdivisions of this, like an administration point, and then you get this spiel. I mean, I did research on where does this come from, because it sort of popped out of thin air, and it's also in a lot of the security certifications like CISSP and all of that. And it's like, well, that's really interesting. But where does it come from? And nobody really knows, because there's nobody cites these references. So anyway, I did some research, and there's a RFC from 2000, right? 25 frigging years ago. Right? Some of you weren't in IT then. Some of the people on this camp weren't even born then. And there's Wikipedia, and then you go, oh, here's a clue: Common Open Policy Service. That's more or less where the concepts were introduced first. And it discusses provisioning models and outsourcing of certain decisions. And the interesting thing is, the original application for this, and that's actually the one that's in the RFC, is for quality of service policies. Nothing to do with security. It basically said, I'm going to tell this device over there that it cannot use more than 1 megabit of bandwidth. And then scale this out across an entire TV network with 100 million subscribers, that kind of idea. So that's where it more or less comes from, as far as I can tell. But if you have better sources, let me know, because I'm kind of interested. Would you also see that Cisco and Check Point use it in their network product documentation in a different meaning than this, by the way, although maybe originally they started using it in the quality of service perspective. And it's really hard to find Cisco documentation from 1999. Right? And I'm not that much of a Cisco expert anyway. So this is a diagram that's often used to sort of abstractly represent how these play together. The idea here is, this is from the Cloud Security Alliance CCSK guidance. So here's where authorization happens. So here's where authorization is decided based on a bunch of identities and attributes and what have you. Who's the person? Who's the device? What's the status of the device? What is the phase of the moon? What's the alert level? Whatever that you want to stick in there, wrap it up in that decision, and then execute it across the real estate or the infra estate. And you could call that defense in depth, right? It's enforced on multiple different levels. And this is a fairly abstract picture, and if you poke holes into it, it's really easy. So defense in depth, you guys know that. Also, other people say it's expense in depth, because you're usually adding layers and layers of cost without actually demonstrating their value. And the authorization happens on the basis of entitlement rules, and here's a process that gives those rules. And this is basically where the Zero Trust strategy lives. But it predates Zero Trust. Anyway, next question. Why should we separate the enforcement point and the decision point? And does that help us understand their functional differences? Say again, Martin? Well, yeah, but if you dive into some of the examples, you'll find that that it's a kind of fluid, right? And you can even have multiple levels of that. Now, for example, I have a rule. I want the rule enforced, right? Now, at the outer perimeter, somebody's asking, "Hey, what should we do?" And then you can go back to a central point, or you can just push all those policies downstream. I'll get to that. The first reason is that you want distributed enforcement points. And this is logical when you think about, for example, the quality of service stuff. Because quality in a let's say, a wide area network, you want those policies enforced on the other side of where the bottleneck is, more or less. The other, so latency, volume, or indeed functional reasons, like I just mentioned, different technologies for those PEPs. Remember, we're enforcing decisions on multiple defense layers, right? And those will have different enforcing technologies, cost, and whatever. I'm still thinking about this. There's probably quite a few more reasons why you would want to. Security architecture design decisions, more or less, right? Now, and then of course there's administrative, not get into that. An example that many of you are probably familiar with, maybe not in the technical detail, but at least in the effect, is 802.1x, where you can't just plug your Ethernet cable into a random port in your company network and expect it to work. Well, old school, that worked. If you still do that, nie grošo, not good. And how it works is, I have a card or a certificate. There's an authenticator, like a radius server. Sorry, the authenticator, that's in the device, sorry. That is as close to the network access point, or the plug, as a matter of fact, as can be. And that's what you want, because you don't want to have that traffic go all the way to a central point. That's the whole point of the network. And then you have an authentication server, possibly like radius. So PAP is the authenticator, which is typically in the network switch close to the port. And there's a single authentication server, or at least two of them. Right? PDP. And this works, right? And it follows that same architecture. But it's just one layer of defense. Because, what do you feed this thing with is a different story. Okay, here's a more extensive example, which is for you to read when you read this at home. And now the confusing thing. There are alternative realities in which we also do these things. So different lines of reasoning that brought us to, let's say, the same kind of approach. And that's what the Cloud Security Alliance called the software-defined perimeter. The use cases here are fairly interesting. And the way I always explain this in the cloud security training is that you have, like say, think of this as your data center, and this as more or less your firewall, right? And then your admin is on the outside, or whoever it is, the SDP host. Well, this is internet, so host is basically your PC. And when it wants to, let's say, access a service, let's take a more specific example. And this guy worked through some of those examples when he was one of my students, right? The idea is, okay, let's say there's an admin, and the admin needs to do some maintenance on an SAP server, or whatever, the disk ran out, or up patches, or whatever. They cannot go directly to the server. That would be totally stupid. You even also don't want that server exposed on the firewall, not even as a blocked port, right? It has to be completely invisible. So you talk to the SDP controller that said, hey, I'm Joe or Jill from that department, and I need to log into that server. Now, here's where you stick your policies in. And one of the policies, and I heard this exact scenario from a vendor of this stuff. So, okay, this controller will have a look at, okay, who are you, right? Since you're an admin, does your name appear on a ticket in ServiceNow somewhere, right? Does that ticket actually involve the server that you want to log into? And if that's the case, then we'll give you access for half an hour from that exact IP address only. That's the kind of thing that you could be doing. Now, if you look at that sounds quite a bit more secure than what we used to do. But the problem is, one of the problems, and I'll briefly touch upon that at the end, is that this uses completely different words for basically the same concepts. Okay, next up. How do we write these frigging rules, right? The access rules. Well, here's the interface really to operational risk, right? This example, again, a little bit too detailed possibly. There's a HR application, and there's a couple of roles that have access to that application, and the attributes here say, okay, do we know the organization? Do we know the user? Do we know the device? Is the device clean? Is it patched? Are we on our local network or on another network? What are the roles of these people? All these things that you can stick into a decision and out rolls a decision. And this is a way to minimize, in a way, access, but also to minimize trust. And if you don't trust somebody to be a manager, don't give the manager access, right? So this is a general idea. The reason why I'm pointing this out is you need to get this info from the people that run the process, not from the technical people. It's not even in the policy. It's their data. They should know what data is important and what level of risk they are comfortable with. Are you comfortable with the HR manager doing stuff from home? Well, maybe, maybe not. Now, John Kindervaag and also other people are using what they call the Kipling method for designing or creating these rules. So Richard Kipling, a famous writer, I think he wrote the Jungle Book, if I'm correct. He said, well, as a writer, my 6 honest serving men are who, what, when, where, why, and how. Journalists have the same idea. And that helps us create these policies. The same basic idea, with slightly more text, appears in the NSTAC report that John Kindervag helped write, which led to the executive order. So this is real stuff. Except that report, this is all there is on it. Right? No explanations, no examples. This is it. Right? Okay. Great guidance, guys. How are we going to implement this across the entire Department of Defense and the rest of the government? Okay. This is where I have to step in and help get some more examples. Here's an example that John gave in a masterclass that he did in Zurich last year. I attended that one. And he gives some examples. Okay. Who? Okay, what is the resource? So it's not actually not the resource, it's the person trying to access something. Endpoints, what's the asset name, workload name? It's kind of odd. How do we validate the application? What is the application that we're trying to access? It is a bit messy. I mean, it looks pretty nice, but if you try and sort of give hard and fast rules as to how to write this, it kind of falls apart. I was totally confused about this, really. Although if you sort of every line sounds reasonable. Okay, AD admins can do AD app validation anytime on the domain controller, right? Why? Well, because we want to, right? And how? Well, we check the AD meta tag. Now, I'm not an AD person, so this is kind of gibberish to me. And then allow. And of course, here's the thing. You only do allow rules, which means that if something is allowed, you can figure out which rule allowed it, which makes for a lot easier audit. By the way, so who of you has done with firewall maintenance or configuration, even on your home server? In a commercial setting, a little less. A couple of years ago, I was giving a presentation or a cloud security workshop at a bank in the UK. And at some point in time, these guys told me that I forgot what the exact context was, probably a story like this. And they were like, okay, how long did it take to get that rule implemented? And part of the part of the job was outsourced, and it was anywhere between 6 weeks and 6 months. And the most excessive case for changing a single or 2 firewall rules, where they got quoted £750,000. Now, why is that? Oh, there's another story I tell about that. All right. How many rules does an average firewall have? I asked this a couple of times of a couple of people. 10,000, 2,000. Well, the most often quoted number I had was 2,000. Why it's 2,000 and not more? Because beyond that skill, nobody understands it, right? And that's why it's taking £750,000 to go over each and every rule. So this allow works against that, deny, and then that, and then the IP address, but it's actually an application. Nobody knows shit what's going on. Anyway, so the rules are already a little bit funky. And the next question is, okay, where do we enforce this? Well, I already explained to you, you can enforce them in many different ways. Again, that's engineering. And the whole zero trust concept or word is how do you say that? It's not a red herring, but it's a decoy almost. It's not zero trust. It cannot be zero trust. There's always some trust. So how do you manage that trust? That's the more interesting question. Is there something breaking apart, or is that part of the war zone soundscape that we're having here? I don't know. One book that I like quite a bit because it's definitely more detailed, and I'll give you the quote at the end, is Zero Trust Security that Jason Garbus wrote. Also a nice guy who knows what he's talking about, also involved in CCCT. And he says, well, he simplifies it because he ran into the same problem. He said, well, who should have access. Subject criteria. What are they allowed to do, right? And on what device or what target? What data are they allowed to access? And any additional conditions, even though some of the conditions could also be specified there. Again, that's where it gets messy. And here's just a copy of the book. Subject criteria, your action, target, condition. So what he says is members of the group, the billing department, they can access the billing website or something, the internal billing website. And if they're not local, we should prompt them for MFA. Fair enough. This probably secure enough for this data level. So this is the way you could be doing it. In more detail, subject is the entity performing the actions, an authenticated identity, typically. Not yet authorized, but definitely authenticated. Maybe specifically which are the subjects, and then, I think I covered the rest. So these attributes, and I already spoke about that in the earlier diagram, can be derived from many different sources. Who's the user? What IP address are they on? What's the ASN number of the IP address? What is the what's the botnet ranking of that IP address, and so on and so forth. But the question will always be, to make it more specific, how do we know these things at the place of the policy enforcement point? That's what in the engineering what you want to do. Okay, flashback time. We used to do this all the time, except we use simpler examples and words. Now, any one of you familiar with this line? Right? Okay. This has been around since probably 1971 or something, when the first versions of Unix were developed. and really, you can apply those concepts to that, and maybe that helps understand what's going on a little bit better. So the subject is the effective user ID and group ID of the process trying to execute the system call read, because that's basically what's going on. The criteria are based on, is that user part of a group? At least that's not always necessary, but often it is. What are the actions? Well, we can do read, we can write, and we can do execute. Now, for those nitpickers, there's also a set user ID bit, I know. And I didn't even know when they invented it. The target is definitely this file, and the conditions are, well, they're hard-coded in the kernel, more or less, based on these few things. Now, this is nice, easy, and simple. Why did we complicate things beyond the beauty of vanilla Unix, right? Anyway, and you can see, of course, that in today's cloud world, these actions, like for every type of object, every type of target that is in Amazon Web Services, this list is about 100 different actions long. And they're adding them on a daily basis, and they don't tell you, right? But the basic principle is the same. Okay, more examples, because we need examples. So here's a Kubernetes example, right? And here's a way to do allow. Well, Kubernetes, in a way, is unsafe out of the box. Well, not completely true, but it doesn't really add much security out of the box. Now, you can do that with CNI, so customer network interfaces, and some of them have better security than others. You can always write this policy, you just hope that your CNI will be able to execute it. So, for example, you have a network policy, the metadata is name, it's called web allow, we call it web allow, whatever. It applies on a specific pod, and that has it applies on all pods that have the label busybox1. This is just an example. I actually have the code on my website, and it allows ingress from whatever pod matches this label. So this is an allow rule that says all the pods that match this label, let's say, can access our busybox1 and deny the rest. And interestingly, the PEP and the PDP in this case are both inside Kubernetes, and more specifically in the CNI, if I'm correct. Am I correct? Yeah, I have my sidekick here. The policy administrator, which we didn't discuss much, is likely to reside somewhere else. Because in a way, this document is the interface between the policy administrator and the policy decision point. And you would do it through Argo CD or whatever. So that's the Kubernetes example. Now, how are you going to write these by hand? I don't know. Probably. Okay, as I said, unifying the terminology. Zero Trust talks about PEP and PDP. SDP talks about controllers and accepting hosts, which is basically the same thing. And then there's more FUD around these Kipling rules like attributes, targets, criteria. This is confusing, right? The reason why I'm telling you is not to show that I didn't study this enough, and maybe I did, but the world is confused about this. So you better be aware of that. Is that okay with you guys? Yeah, good. And then the CTA as defined by NIST, which is what the executive order talks about. It really talks about the PEP PDP. So that aligns with that, even though it reinterprets stuff that was developed in the late 90s for a completely different purpose. Here's an example of a product. Now, I don't know the product exactly, but I was at the demo. This is a Dutch guy, by the way. Now, it's a little hard to see, and I was in the back, so my camera wasn't sharp enough, but I could deduce a couple of things. What this basically says is, here's a bunch of devices on the network from which we allow connections to actually the same groups of devices. And this is more, I mean, in a simple firewall architecture, you have inside, DMZ, outside, right? That's 3, right? This is like 20 by 20. To give you some examples that you could, to give it more, to help you understand this. Here's a column of stuff that basically everybody has access to. What is that? I think it's probably DNS and NTP. Makes sense, right? Here's one system that basically has access to everything. That's probably the VDI pool, as far as I can deduce. Makes sense. But you'll also understand that this is not a full, complete close down of all possible traffic. So you need additional rules like these. Now, if you can use, a tool like this, if you can sort of push all those decisions around in your network and your firewalls and whatever, based on application names rather than IP addresses that you have to manually look up, you can see that this is going to give you a lot more trust than your basic flat network. So I kind of like this as an example, but it's just a piece of the puzzle. Okay, more rules of thumb that just to help you think this through. One is that if you see the word block or deny, and it is not followed by the word all, right? We have a problem. Because this will lead to a situation in which we cannot easily understand what the firewall rules together are actually doing. It's hard to understand what the effect of this is, right? So there's implicit trust here. You just have to find it, search and destroy. Another one is, this is more like a practical thing, monitor the blocked stuff. Because you don't know if the rule still works. If I change my Kubernetes installation and the CNI happens to be changed and it no longer understands the network policies, you're toast. Actually, this is what I want to do on my home network, where I'm going to red team my solar panels. Maybe for next edition we can do that. I hope to have done it this time, but yeah, I ran out of time. Now, AI and Zero Trust. This is work in progress, but I'm going to give you a couple of more tips. Never trust anything that comes out of an LLM. Especially not when it is about an identity that you should trust, right? It's not to say that you can't use LLM in security. For example, you can say, well, we have a baseline of what we trust, and the LLM can watch as well. This is actually a little bit more suspicious than we think, right? Downplaying security rather than, let's say, authenticating. Another is, and never trust. Credentials are like, I say, that stuff for grown-ups, right? Handle with care, right? Don't let an LLM handle those. You never know what they're going to do with it. Before you know it, they're all over the internet. So never allow the LLM to touch any of your credentials. Now, this is inconvenient, possibly, and that's why people do stupid shit, right? But I'll give you an example of how I'm doing this, which I think is fairly secure. So I have Cloud Code creating a bunch of stuff and actually pushing it to production through a Git action workflow to a server. And the way it does it is that Cloud Code has access to the GitHub command line tool, because it's agentic coding. But the GitHub command line is authenticated to my GitHub, but there's credentials there that the Cloud Code can never access when they're outside of the scope of what it can access. The only thing it can do is go, I can call GitHub, is what Cloud Code says, and I can tell GitHub to do stuff with certain credentials, and that's it. It cannot do anything else, and it definitely cannot get the credentials that I use to give GitHub that access. Those are the tricks that you want to play in a DevOps pipeline. And this is more extending it to AI-based coding. There's a great Cloud Security Alliance paper especially on this stuff. It is, what's it called again? Securing LLM-based applications. Who would have guessed? I actually ran a course on that. Okay, now how do we retrofit? I'm actually running almost out of time. Retrofitting Zero Trust to an existing situation. This is a challenge somebody put me. And here's the example. Okay, I have an application. There's people that have access to that application. I call these things control boundaries, by the way, and this is an execution environment. For more details on how to use these diagrams, I have a talk on that tomorrow at 8 o'clock at night. And then you can ask yourself, okay, yeah, there's too much trust here. How can we add trust to that? Maybe we cannot do MFA on this because it's a shitty architecture, but what can we do to improve it? One thing we can do is, okay, what's the real risk here? Time of day, source of IP filtering, maybe specific users. And if you think through what is the biggest risk, well, it's exfil of data, of course. And the example was like, we have some CRM system. Okay. What's the difference between being able to pull 2 or 3 records out of that versus downloading the entire frigging database, right? Is there a difference in risk? I think there is, right? Actually, our network-based Zero Trust doesn't cover that. It's something that the application owner should be thinking about. Maybe you want a 4 eyes principle for large downloads, right? Okay, you want to download 1,000 of these or the entire database? You better have a good reason, and I'm going to ask somebody else to acknowledge that as well. This is not technical. This is a business process level decision. Anyway, if you look at this type of environment, the other thing that you always want to be looking for, and this is more or less new, is, hey, what happens if, maybe there's malware inside, right? And Zero Trust says, assume breach, right? We all know it's not a question of if you're being hacked, but when you will be hacked, or even did you actually notice being hacked, right? We all know that a threat actor with sufficient resources will get there. But then you can apply Zero Trust. It sounds like somebody's tapping on the floor, right? But it's that noise outside. Right? What can this thing do, right? Of which we don't, we have to assume something like that exists. How much do we trust it? Well, not very much. So what can we do? This environment should be limited in what it can do. Can this server go anywhere on the internet? Should not be. And this is what I want to do with my solar panel, by the way. Right? I want to know what my solar panel is phoning home to. Beyond, and actually never mind. We can talk this over on a beer. So implementation steps, how you do this. I recommend the CCTZT courseware, which is free, lots of good stuff. Takes some going through. This is what my course was on, but I'm not sure if I'm be able to give that again. Maturity models, this is based off a Microsoft-originated maturity model for Zero Trust, which is pretty decent, even though it is Microsoft-specific. But there are others, there's like 10 or 20 out there. And if you do run through this, which my students did, It is another interesting lesson here. So you get like, okay, this is the minimal, this is the best, and this is what this particular organization had, and this is what the other particular organization had. So you can see that these guys are really strong on device management, and these guys are a bit better on infrastructure management. Interesting, right? And then you can sort of plug the holes as you wish. What I found most interesting in the discussion that I had with these people is that it's the data bit that has the least controls. And when we dive into that, what we find out is that there is no proper governance on data. And why is that? Well, the governance rules on data have to come from the actual data owners. All the other stuff we know as IT people how to do. But we don't know what's really important data. And if we don't know what it is, everything is important. And if everything is important, we don't have time for everything. And that's why that sucks most of the time. And the Zero Trust Handbook really says, well, you have to talk to the stakeholders to figure out what you want to have done there. Some tactics, some steps, protect service, transaction flows. Anyway, I'm not going to go into that in more detail right now. This is all basically from the books, and it's explained better there. There are steps and processes, there are design principles. I'm not going to teach you that. It's a 2-day course to go into a lot of detail there. Some common risks and fears, because there's emotions around Zero Trust. What, you don't trust us? And who's going to do all those rules? The security guys? They already have too much power. Will they become security dictators? Then we don't want that. Off you go with the Zero Trust. We don't want to hear about that. It's too complicated, so you have organizational paralysis. We all know that. It overflows our context windows, so we don't do nothing. People are like, well, we never had control anyway, so this is all a pipe dream. Or maybe it works as designed, and then our workers will become dehumanized because they can only do stuff between the lines, right? Anyway, I'm going to skip this one as well. Further reading, Zero Trust. This is the body of knowledge. This is more an architecture enterprise guide. It's a pretty decent book, but you have to be an enterprise security architect to really appreciate that. This is probably the best book to start with. The Project Zero Trust by George Finney, which is a business novel. So it's a story with real people that do really normal, stupid mistakes. It's a good read, and it brings Zero Trust to life. How can you start going with it? It's a real life company. Okay, what else? So as I said, tomorrow, deployment diagrams, which I present somewhere else, which is a useful tool in diving deeper into this. Another one that I saw, I don't know this guy, but I'm going to be there, right? Can we trust the Zero and Zero Trust? Well, the answer is obviously no, but the detail will be more interesting. And we have still 4 minutes. A shameless plug, I'm writing a book. Say again?
We need to wrap up.
Okay, good. Here's a book that I'm writing. You can buy it on Amazon Kindle, but if you take a business card there, you can download it for free on my website. No registration required, so that's why I feel free to help you. I want to know your feedback on this, because this tries to tie together a lot of the things. And now we really have to wrap up. Any quick questions, as many as that guy allows me to answer, or allow you to ask.
I'm afraid for time.
Yeah.
The next talk starts in less than 5 minutes, so we're probably going to have to wrap up. We're going to have to wrap up because actually there's a really interesting subject we've been talking about. I'm sorry, the slot.
No. We can go to the bar and discuss it further, right?
Buy Peter a drink. Does that work?
I'm in for a drink, right?
Thank you very much. That was super.
Thank you.
That was great. Thank you.